Hello, my name is Trey Holt,
I'm Caitlin Freeman.
and today we will be proving that pi is irrational. Pi has had an interesting history. First, Johann Heinrich Lambert proved that it was irrational. Then, Charles Hermite proved it in a much more simplified way. Today, we will be doing a proof by contradiction, specifically Ivan Niven's proof. Here are the steps in order to prove pi is irrational. Our first step is to assume pi is rational. We will do this by setting pi equal to a divided by b. Next, we will define functions f of x and g of x. Then, we'll do some complicated math in which the Wikipedia says is simple calculus, but I took Calc 1 and I don't think it's that simple. And from this, we'll get two contradicting statements. Finally, we'll conclude pi is irrational by contradiction.
After assuming that pi is rational by a divided by b, we get our two functions here, f of x and g of x, from Niven's proof. F of x here is this crazy little function that we then plug in to our g of x function, in which we get f of x minus the second derivative of x plus the fourth derivative of x, so on and so forth, until we get negative 1 to the n times the f to the 2n derivative of x. That's our function we'll be using in the further parts of our proof. So using our functions that we defined here, we can take the derivative of g prime of x sine of x minus g of x cosine of x, which boils down to the simple f of x times sine of x. And then we can evaluate that integral from 0 to pi, and it gets us g of 0 plus g of pi, which is by the fundamental theorem of calculus. And then we can take that and plug it into our inequality here, saying that 0 is less than the integral of f of x sine of x evaluated from 0 to pi, which is less than this constant, a to the n times pi to the n plus 1 over n factorial. Now that we have our inequality, we can graph it out here and see that our f of x sine of x is this, and taking the integrals, we're finding that area, all in the green. And then we have our constant, which is the a to the n times pi to the n plus 1 over n factorial. And as n approaches infinity, that chunk of the function is going to approach 0, so this line is going to come down, squishing the area between the blue and the green until it reaches 0. But because of the inequality saying that we are taking it less than 0, which is this, which is less than that, it's not possible to get 0 is less than 0.
Because it makes 0 sense that 0 is less than something less than 0, this means that by contradiction, pi is irrational. W, common pi W,